Good morning, students. In this session, we are going to see a subject hybrid and electric vehicle technology. From the subject, today we are going to see a topic on switch reluctance motor drives. The switch reluctance motor is an electrical machine that converts the electrical power into mechanical power. This electric motor, similarly to the conventional motor, can operate in a 4 quadrants. In other ways, it can be accelerate and deaccelerate the clockwise and anti-clockwise rotor rotations. The switch reluctance motor control cannot be combined either with the alternate current motor, which is feed the current waves forms, or with the direct current motor. In the simplest control, it needs each motor phase, that is winding, to be magnetized and demagnetized at the right moments of the rotor position. So square current waveforms can be used in the simplest control, but as the motor is highly non-linear, the electromagnetic torque does not depend only the current value but also on the non-linear induction profile, which means the use only a square current waveforms will create a torque in a high ripple component. Due to the high volume of mainstream vehicles in the internal combustion engine, that is IC engine, environmental pollution and energy shortage are now a concern. Electric vehicle can restrict the energy source, and ideal method to save the resource and provide zero emission vehicles. The e-vehicle critical feature is an electric motor and illustrated in the figure, so selection is crucial. In recent decades, many types of electric motor can evaluate and analyze for e-waste. Currently, the switch reluctance machines are attracting attention in the research community because of their various advantages. These operate with the overall efficiency compared to an induction motor having the same rating, as the windage and friction losses is identical. The article introduced the switch reluctance motor as its the operating principle along with the pros and cons. Finally, the current control method for switch reluctance motor will also be discussed. It is a switch reluctance motor. It consists of rotor, stator, shaft and the coil. The linear controls were presented and the voltage, impulse, current and torque controllers respectively. Depending on the required performance and the cost, a choice can be made from the cheapest with the lowest performance of impulse control to the most expensive with the best performance of torque control. So the linearization need to be performed for control design. It will be seen that ideal current waveform can be calculated to produce constant torque instead of using a square waveform current. About the power electronic device, a description is given of how the traditional switch reluctance motor convert works, and it can be controlled by a maximize performed. The switch reluctance motor is constituted by a stator with a concentrated winding disposed around a polar course, and by the rotor composed by the salient poles free of windings and magnets. Normally, each stator face is composed by the couple of windings diametrically opposed. The SRM configuration of 6 stator poles and the 4 rotor poles is shown. That is configuration of reference for this chapter. It is a switch reluctance motor structure. There is a stator, rotor and the coils. When a stator face is magnetized, a closed magnetic field is generated between the stator and the air gap of the rotor. This magnetic field tends to minimize the reluctance by reducing the air gap, which creates a rotor movement. When a stator pole is aligned with a rotor pole, it is said that they are in position of minimum reluctance, and when they are completely unaligned, it is said that they are in a position of maximum reluctance. This characteristic of motor makes it possible to create a rotational movement of the rotor by magnetizing and demagnetizing each phase in a right position of the rotor. There is a torque characteristics. The switch reluctance motor suffers from high saturation. The induction profile in a nonlinear, making the flux characteristics also nonlinear. It is shown in a figure where the blue line is a unaligned rotor position and the red line is a aligned rotor position. The saturation starts to be influence the motor characteristics from 5 ampere. It is around this point where the torque ampere ratio significantly increases. There is a graph between the magnetic flux and the current. The switch rotor motor torque characteristic graph is shown. It represents a one phase of 90 degree of the rotor and the rest is 360 degree. Are the just a repetition of other 3 rotor poles. The blue line represents a low current profile of 5 ampere and the red line represents a high current profile of 20 ampere and which is a maximum motor current. It can be seen in the form of 0 to 45 degree. The positive torque is produced and from the 45 to 90 degree negative torque is produced. It can also seen that a producer torque is in constant from the constant current. Thank you.